Hello friends, my name is Sandeep Saini and I am working as assistant professor in Chandigarh Polytechnic College. Today we will discuss about your block diagram of your 8085 microprocessor. Last lecture we will discuss about your pin diagram of 8085 microprocessor in which we will discuss about each and every pin of your 8085 microprocessor. In today's lecture we will discuss your internal circuit of your processors microprocessor and the function of ALE. The function of ALE is used to demultiplexes your address and data buses. First of all, I am sharing a PPT so you can easily understand the architecture of 8085 microprocessor. Wait a moment, I am sharing a PPT. This is your block diagram of 8085 microprocessor. I say that architecture of 8085 microprocessor. Our objective is to study the architecture of 8085 microprocessor. In outline, we will discuss about your block diagram of 8085 microprocessor, interrupt signals, control signals, and different type of buses. In today's lecture, we will discuss all four parts. This is your block diagram of 8085 microprocessor. One by one, we will discuss each and every part of your architecture of 8085 microprocessor. We will start from your general purpose registers, or we can say that your register area. There are six type of general purpose registers we are using, just name as B register, C register, D register, E register, H register, and L register. All six registers are your 8-bit registers. If you want to store a 8-bit data, then we can use any of this register, B register, C register, D register, E register, H register, and L register. If you want to store more than 8-bit data, or we can say that if we want to store 16-bit data, then we can use this register in pairs. For example, BC pair, DE pair, and HL pair. We are not used just like your diagonals. We are not using like that, or not we are using from just like we are using C and pair or E and L pair. We are just using we can just use just your B and C register, D and E register, and H and L registers. This is your three pair which we are used if we want to store 16-bit data. Next is your stack pointer. The function of your stack pointer is used to store the address of your top of your stat. As we know that the stat is your last in first out device, just like your tumbler as shown in your displays. Suppose this is your tumbler and we add a different balls name as A ball, B ball, and C ball. We enter A ball first, then after that we enter B ball, then we enter C ball. If we want to exit the ball, or we can say that pop the ball, then first C ball can pop, then B, after that A. That means the device is last in first out. दैट मीन्स जो सबसे बाद में एंटर करेगा वो सबसे पहले हमारा बाहर जाएगा, और जो सबसे पहले एंटर करेगा वो सबसे बाद में हमारा बाहर जाएगा. There are only two instructions we are using in your set. First is your push instruction, second is your pop instruction. The function of push instruction is used to if we want to store the data on your stack, then we use a push instruction. If we remove the data from your stack, then we are using pop registers, pop instructions. This is your temporary registers. Next is your program counter. The function of program counter is used to store the address of your next instruction. In program counter, we can store the address of your next instruction. As we know that the processor is microprocessor 8085 has 16-bit address lines, so this is your 16-bit register. In this 16-bit register, there is 16-bit addresses stores of your next instructions. This is your increment and decrement registers, and this is your address latch. The function of the address latch is used to separate the address and data buses. This is your general purpose registers. This is your temporary register in which the processor can store the data. The main thing is that if you want to store the 8-bit data, then we can use B register, C register, D register, E register, H register, or L register. If you want to store 16-bit data, then we can store the data in your pairs: BC register, DE register, HL register. HL register. This is your pairs. अगर हमने 16 बिट स्टोर करना है तो हमें पेयर में यूज करना पड़ेगा. अगर हम 8 बिट स्टोर करना चाहते हैं तो हम सेपरेटली इसे स्टोर कर सकते हैं. The function of stack pointer is used to store the address of your address of top of your stack. Next is the function of proton router. The function of proton router is used to store the address of your next instruction. So with the help of proton router and stack pointer, or we can say that with the help of proton router, the overall speed of your microprocessor is increased. Next is serial input output control. There are two pins, the name as SID and SOD. The function of SID and SOD is serial input data and serial output data. In microprocessor 8085 microprocessor, if we want to if processor want to get the data from your peripheral devices or your hard disk, then with the help of pin SID, that full form of SID is serial input data. The processor can take the data from your outside. After that, if you want to give the data to your peripheral devices, then the pin is SOD. Full form of SOD is your serial output data. With the help of SID or SOD, we can provide the data to your processor, or we can take the data from your microprocessor. This is a function of your serial input output control. This will two parts of your block diagram will discuss. First is serial output control and second is registers. We'll discuss. Next is your interrupt control. Interrupt, the first of all you have to know that what is interrupt. When the program is running, in between the program, if the higher priority programs jump, at that time processor leave the program at that place and store the data, store the result of particular instructions, and address of that time is stored on stack, and take the address from your high priority interrupt and run your higher priority interrupt programs. After that, it can start from your same location as shown in figure. Thus, this program is running at that point, the interrupt system. So, इस पॉइंट तक हमारा एड्रेस और आपका डाटा हमारा स्टैक के टॉप पे डाल देंगे. उसके बाद जो हमारा इंटरप्ट वाला प्रोग्राम है उसके पास प्रोसेसर चले जाएगा, वो इंटरप्ट वाला प्रोग्राम रन करेंगे. वो खत्म होने के बाद हम स्टैक के टॉप से डाटा लेंगे और दोबारा इस पोजीशन में पहुंच जाएंगे और फिर ये मेन प्रोग्राम अपना रन करना स्टार्ट कर देगा. इसकी हेल्प से हमारे पास क्या होगा, इस तरीके से हमारे इंटरप्ट आपके रन करते हैं. अब we have different type of interrupt. We have two type of interrupt, just as your hardware interrupt and software interrupt. This is your hardware interrupts, name as INTR, RSG 5.5, RSC 6.5, 7.5 and trap. This is a 5 type of interrupt. Trap is your highest priority interrupt. We cannot disable this interrupt. The example of trap is your power failures. The second highest priority interrupt is RSC 7.5. After that 6.5. Then is 5.5. Last is INTR. INTA is your interrupt acknowledgement. This is your bar. INTA bar. This is your interrupt acknowledgement. This is active low pin. When this pin is 0, in that case, the interrupt is handled by a microprocessor. When the value of INTA bar is 1, in that case, microprocessor not handle the interrupt. Okay. Next is automator. We will discuss your interrupt control, serial input control, register sets. Next, we will discuss about automator. In 8085 microprocessor, there is 8-bit automator. In automator, if we want to perform any arithmetic and logic unit, then at least one operand is stored in automator, and second operand it can store in registers, address, registers or hard disk anywhere else. So we can apply the command on automator and registers, and result is stored in your automator by default. Suppose the data is stored in B register, that is 02, and in automator we can store 02. If we apply a command, that is your add B, in that case B is added with the automator and result is stored in automator always by default. Okay, this is a function of your automator. Next is temporary temporary register. This is temporary register. We are not able to use this register. The microprocessor can use this register if they want to store any data at particular time. Next is flat flip-flop. After that, we'll discuss. There are 5 types of flat flip-flop: your signal flag, control flag, signal flag, auxiliary flag, carry flag, parity flag. In next slide, we will discuss. Next is instruction register. In program router, we can store the address of your next instruction. In instruction register, we can store your next instruction. Here, the address is stored. Here, the instruction is stored. Next is instruction decoder. We have different type of machine languages, just like your machine level language or your high level language, low level language, or it can convert your instruction into machine level language. According to that, the signal is provided to your time and control unit. Okay. So we can discuss about accumulator, temporary register, your decoder, ALUs, instruction register. Now this is your time and control unit. This is your different pins. This is your plus 5 volt and ground. This is your power supply which we required to on the microprocessor. Next is S1 and S2. In S1 and S2 we are using 5 megahertz crystal oscillator. So we can apply the 5 megahertz crystal oscillator on S1 and S2. With the help of this, the microprocessor can run. Next is clock out. The microprocessor is apply a clock to your peripheral devices, so all ICs get synced with each other. Next is ready. The speed of microprocessor is more than your peripheral devices. So if you want to transfer data from processor to microprocessor to your peripheral devices or your peripheral devices to processor, then there is a ready signal. If the receiver is ready, after that the data communication can form, otherwise not. Next is your control signals. There are 2 types of control signals, that is RD bar and WR bar. The mean of RD bar is your read bar. This is your active low pin. The function of this pin is, if this pin is value of this pin is 0, in that case the microprocessor performing the read operation. If the function if the value of this pin is 1, in that case the microprocessor not performing the read operation. After that, WR bar. If the value of this pin is 0, in that case, microprocessor performing the write operation. If the value of this pin is 1, in that case, microprocessor not performing the write operation. Next is ALE. ALE is mean address latch enable. It is used to demultiplex your address and data buses. Next is your status. With the help of S0 and S1, we can identify which operation is performed at particular time on microprocessors. So these four combinations, that is 0, 0, 0, 1, 1, 0, and 1, 1. In next slide, we will discuss about their combinations. Next is input output / memory bar. The function of this pin is used if the value of this pin is 1, then the microprocessor perform the operation with your input output devices. If the value of this pin is 0, in that case, the microprocessor perform the function with your memory. Next is DMA. DMA pins. There are two types of pins, hold and held. HOLD hold, HLDA held. If we want to transfer a bulk of data, or we can say the large number of data, then processor use your peripheral devices, that is DMA controller. To control the DMA, there is two control pins, hold and held, which are connected with your microprocessor. Suppose we want to transfer your movie to your pen drive to your hard disk, then then if you want to give the command to transfer data from your pen drive to your hard disk, first we apply a signal to your DMA controller. Then DMA sends the request to your processor, that is your hold. If that time the processor data buses or address buses are free, then positive acknowledgement of held is received by DMA controller, and after that data can transfer from your pen drive to your hard disk or vice versa. जितना टाइम हम हेल्ड, जब तक हमारे पास हेल्ड अपनी रिक्वेस्ट नहीं आई, पॉजिटिव एक्नॉलेजमेंट नहीं आई, तब तक हमारे पास डाटा ट्रांसफर नहीं हो पाएगा. नेक्स्ट इज योर reset in and reset out. The function of reset in and reset out is, if we want to reset the processor, then we apply a 0 signal on reset in, so processor can reset. The function of reset out, if the processor want to reset your peripheral devices, just your keyboard control IC, your DMA IC, your input output device control ICs, then it can reset with the help of reset out. This is the function of reset in and reset out. This is the most important topic of your microprocessor, that is your block diagram of microprocessor or architecture of microprocessor. Next is address and data systems. As we know that there are 16-bit address buses, 80 to 87 address buses are multiplexed with your data buses, and that is your bidirectional buses. A5, A8 to A15 is your unidirectional buses. This multiplex buses are demultiplex with the help of your ALE, that is address latch enable. Next is after that control signals. We have four main control signals. First is ALE, that is address latch enable, we will discuss earlier. If the value of ALE is 1, then on pins of 0 to 87 have an address. If the value of this pin is 0, that case the pin 80 to 87 dot the data. RD bar. RD bar is active low pin. This is your active low pin. This is your bar and this is your bar. This is your read bar and write bar. We already discussed this function. If the value of this pin is 0, that means the read operation performed the value of WR bar is 0, that means it's the right operation. This is input output slash memory bar. It perform show the microprocessor perform with your peripheral devices or your memory. Next is S1 and S0. There is 4 combination of S1 and S0. We'll discuss in next slides. Next is your flag registers. There are 5 type of flag register. First is your signal flag. Signal flags have the value of your result is in a negative, then signal flag is 1, otherwise signal flag is 0. Next is your zero flag. If the resultant is 0, in that case the zero flag is high, otherwise zero flag is low. Next is ALE. If the carriage is generated from D3 to D4, as we know that, suppose this is your D0, D1, D2, D3, D4, D5, D6, D7. If the carriage is generated from D3 or D4, suppose this is your data. If we carry generate, or if we want to add this two values, that is 1, 1, 0, 1, that is 0, and carry is generated from D3 to D4. The carry is generated from D3 to D4. That case, the auxiliary flag is high. Otherwise, this case auxiliary flag is low. Next is parity flag. There are two type of parity: even parity and odd parity. In name of parity, the number of ones is even. In that case, the parity flag is 0. If the value, if the number of one is odd, the parity flag is 1. Next is carry flag. If any carry is generated from any pin, in that case, the carry flag get high. After that, overflow flag is if the data the resultant is more than your memory space, that case the overflow flag get high. This is your control signal. We will discuss your input output device or your S0 or S1. When the value of S0 and S1 is 1, in the case of input output device slash memory bar is 0, then the operation is read. Input output device is readed. Same as it is, that is memory read, then after that memory write. Next is input output read and input output write. After interrupt acknowledgement. This is your control signals. Next is interrupts. Your trap RST 5.5, 6.5, 7.5, INTR. The highest priority is trap. Second highest priority is RST 7.5, then 6.5, then 5.5, and last is INTR. This is your block diagram of 805 microprocessor. If anybody have a doubt in any part of your 805 microprocessor, then you can call me, mail me, or WhatsApp me according to your convenience. Okay, thank you.